Okay, students, here is lesson 1-4, which was covered today. This lesson over transformations of graphs is particularly more about learning by doing. But at the beginning of the class, we went over this handout that I'm displaying right now that is serving as a reference sheet as you get accustomed to identifying those transformations through practice, and eventually this reference sheet will become obsolete. That's what the goal is. So let us go over this reference sheet. If you have your copy, pull it out. If you were not in class, go to Canvas and you can retrieve that copy. So first of all, there is a specific order to the operations of transformations as you see listed 1-4. These are the operations that you are going to look for when you are identifying the transformations. So either you are going to be given a parent graph with a transformed graph, and you are going to have to identify what those transformations were, and these are the assortment of transformations you would come up with. Or what's going to happen is I'm going to give you the equation of a transformed graph, and going by that equation, you're going to identify what happened and be able to graph the new graph given the parent graph. So let us start here. So the order of transformations, the first one you would first look out for is your horizontal movements. Horizontal shifts have to do with left and right movement. Next is going to be dilation, which has to do with your stretches and your compressions. In order to see if your graph has undergone a stretch or a compression, you are going to specifically look for a coefficient in your equation. And this coefficient is either going to be the coefficient of an x coordinate in your function, or will be the coefficient of the function itself. So when you identify this coefficient, you are going to end up multiplying that number that you identified by either your x or your y coordinate, depending where it is located. Next is going to be your reflection. The reflection has to do with you identifying negatives, and that's super easy for you guys to do. Students tend to not have issues with that one. And then last but not least is your vertical shift, and that has to do with whether or not your graph is moving up or downwards from its original parent function standard form. So how are we going to do that given an equation? So if I move a little further down here, you are going to have a chart, and this chart is very busy and it seems very, very difficult to read, but I'm going to help you understand how to read it, okay? Now, first of all, we already talked about the order of the transformation. So on your sheet, if you haven't done this as yet, what I want you to do is I do want you to write down some text. Let me see where I can write it. Oh, it's not letting me. Okay, I'm going to write down number 1, 2, 3, 4 here first, and then you'll see what I'm talking about. So number 1, I need you to put it by horizontal transformation. So write a number 1 right there. Then I need you to write a number 2. I need you to write that number 2 next to vertical dilations. So that's going to comprise these two right here, vertical and horizontal. Then number 3 is going to have to do with your reflections. And so let's move this number 3 right here with reflections. And last but not least, we're going to do number 4, which is your vertical shifts, and that will be right here. Okay, so please do recognize, though, that when you are looking at vertical dilations, which is step number 2, you're looking at 2 different rows. And when you're looking at reflections, which is step number 3, you're also looking at 2 different rows. So first of all, with horizontal translations. Horizontal translations has you focus on whether or not there's a number adding or subtracting with an X, okay? I want you to notice too that the numbers that are adding and subtracting are always trapped within parentheses, okay? So notice that there's a parentheses here and here, and horizontal transformation occurs inside parentheses. You are always going to do the opposite of whatever the value is telling you to do. So what I mean by that, notice here this says minus a number. If it says minus a number, you're going to think go left, but I need you to do the opposite. And I need you to actually move the graph that many units to the right. Do the opposite, okay? Here, if I have, for example, let's put a number in for the letter B. Let's say this said x plus 3. You are going to want to go to the right 3, but because this is horizontal translations, and because I've told you here you need to do the opposite, x plus 3 means go 3 units to the left. So you will take that graph and you'll move everything 3 units to the left. And that's easily done on Delta Math, as you will see soon. So key thing to remember, please write this down if it's not on your paper, that horizontal translations has you do the opposite. So always do the opposite, highlighting here. Plus B meant go right. Minus B, let me say it again, says to go right. Plus B says to go left. Do the opposite, okay? All right, next we are going to do step number 2. Step number 2 has to do with vertical dilations. Honestly, step number 2 is the area students mostly struggle with, okay? Step number 2 is where people struggle. So I want you to pay close attention to what I'm going to say. So your goal is to find coefficients other than 1, okay? So notice here they're telling you numbers that are greater than 1 or numbers that are between 0 and 1. So not 1, you don't want numbers that are 1, okay? So here's what I'm saying. If you have a function and you have a number multiplying by that function, okay, that number C, okay, now I know that's a letter, but that C represents a number. So that's why I'm saying that number C. Whatever that number C is, if it's in front of the function, what you are going to do is you're going to take that C value and you're going to go find a point. And when you find a point that you're going to choose, I'm going to take that number C and I want you to multiply the Y coordinate of that point by whatever C is. That's what I want you to do. So for instance, let's say I said that C was the number 5, okay? Let's say C was the number 5, and number 5 is multiplying by whatever that function is. We don't care. I don't care what the function is. But that 5, what you're going to do is you're going to pick a point on your graph. And whatever that point is, okay, whatever that point is that you chose, you are going to take this number here, the Y value of that point, and I want you to multiply it by 5. And that's going to be your new point. So for instance, let's say this was 3, 2 originally, right? It's going to become 3, 10 because you're going to take that 5, which was your coefficient, and you're going to multiply it by the 2. So this is your original point. That will be your transformed point. So that is if the 5 is in front of your function. Okay? Now, let's say instead, now that this time your number is not in front of the function. Let's say your number D is in front instead of your X. Now, if that's happening, that's going to be a horizontal dilation. Okay, what we just finished doing was a vertical dilation. That's going to be a horizontal dilation. Notice that your number is multiplying by X. So think of X axis as being horizontal. That's a horizontal dilation. So what you're going to do is you're going to take that D value and you're going to come over here, walk over, and you are going to take the reciprocal of that D value. And whatever that reciprocal is, you are going to multiply it by X. That's what this means. Okay? X over D means multiply the reciprocal of the coefficient you had by X. So let's make a number here to help you understand. Let's say my D value was the number 1 over 2, okay? Let's say it was 1 over 2. Wow, that's like a really bad 2. All right? Now, so what am I supposed to do with that number? Well, my instructions to you were that you would take this D value and you will walk over to this position, to the X position, and you're going to convert that 1 over 2 to the reciprocal. What's the reciprocal of 1 over 2? Hopefully you have said 2. And then you are just going to multiply it by whatever your X coordinate is, and you're done. So making up an example, let's say your X and Y was 5, -3. That's your original point, right? What does it become if your D value was 1/2? Well, what you told me is that 1/2 became a 2, and the 2 has to multiply by the X. What is 2 times 5? 10, comma, and then my Y value stays the same. So my transformed point is 10, -3. So you went from X to 2X, which is 2 times 5, and the Y's don't change. Okay, so you always take the reciprocal. Whatever the D is, take the reciprocal and multiply it by X. Here, whatever C is, you just take that number and multiply it by the Y. Okay, you don't take the reciprocal up here. So if you want to remind yourself of something, I would write reciprocal right here so that you remember. Okay, so let us go to an actual problem. So I'm going to come over here to, I think it was over here. There we go. So here's some examples. So here you have a function, and we can tell that this graph went to the left 2, and then it flipped. Okay, the black graph changed into the red graph. So it went left 2. Left 2 in horizontal movement means that you do the opposite of whatever it's doing to the X. So left 2 means you are adding. So that means it's going to be either this one or this one, because I'm either adding to the X or subtracting to the X. Since the black graph went left, that means I have to add 2. Okay? I need to add 2 because I need to do the opposite. And I know it's going to be negative because it's going to flip over. So notice how my black graph flipped over to be my orange graph. Okay? So let's submit the answers to C. And it worked out. Okay? Let's see if we can do another type. Let's go to something like over here. So here's an example of what we need to do. So the first thing we want to do is, looking at your reference sheet, check to see if there's any horizontal movement. So horizontal movement means that you are adding or subtracting to your X value. And in this situation, there's no adding or subtracting happening to my X value. So horizontally, this graph is not moving. Okay? So what do we do next? Number 2 is dilations. Is there any stretch or compressing happening? So we look for coefficients. Now we notice that this here, 1/2, is a coefficient. And this coefficient is multiplying against the entire function. If it was multiplying by the coefficient of X, it would be right inside here with the square root. Okay, so it's not directly in front of the X, it's in front of the entire function. So going back over here, just to make a point, you are looking at this one, okay? Our 1/2 is multiplying by the coefficient. It's not multiplying by the X, okay? So if we're multiplying by the function, I'm supposed to take that coefficient and multiply it by my Y. So let's go do that. So my 1/2, I need to multiply it by my Y. Now I can choose any of these points. It does not matter which one you choose, okay? but I need to choose out of these 3 points, I'm going to pick the y value that's easiest to multiply by a half. So let's see, this dot here has a y value of 3, because this is my y-axis. This dot has a y value of 2, and this dot has a y value of 1. Well, this dot is the easiest y value to multiply by a half because a half of 2 is just a 1. So I am going to take this and I'm going to vertically dilate to 1. Do you see that? I'm going to start over here. Again, I'm taking this y coordinate, which is 2, and I'm multiplying it by a half, and 2 times 1/2 is 1. So I need to change my y value from 4,2 to 4,1. The x value does not change. Okay, look over here. Notice my x stayed as an x. My y is the only thing that got multiplied. Going back here. Next, so that took care of that half. That negative now is in front of the function. That 2 is in front of the function. So if we look here at our negatives, this negative is in front of the function. This negative is in front of x. When it's in front of the function, I'm going to reflect in the x-axis. That means I'm going to jump over the x-axis. So I'm going to take this point or this point or this point, and I'm going to jump over this x-axis. Well, the easiest one for me to jump over is this 4,1, because if it's at 1, 4,1, then it has to exist at 4-1 when you reflect it over the x-axis. And then I'm done. Now I'm going to submit. Excuse me. And we got it right. Let's try another problem. Here's another one. Here we notice horizontal movement. Notice that we have a number adding to our x. So that's horizontal movement. We do the opposite. So I go left 4. Then I check for vertical or horizontal dilations, which I do have because of this number. Notice this number is multiplying by the whole thing. So it's going to change my y values. So I'm going to multiply 1/2 times the y. Which one of these is a good one? So this y value, because this is 1, 1, this is 2, 0, 0,2, and then this is 5,3. So between 1, 2, and 3, this one's the easiest one to multiply by a half, because a half of 2 is a 1. So it vertically compresses. And that's it. There's no other movement. There's no negative, so there's no reflection. There's no number adding on or subtracting here on the outside for vertical movement. So I'm done. Okay, let's see if we can go and do a level 2 here before we wrap up this lesson. Here we got another one. Okay, so here we have an absolute value graph, a V-looking graph. So we start first with horizontal translation. We look at our x. Our x is right here. Notice that our x is not adding or subtracting with any number. So our horizontal movement is not going to change. Okay, it's going to stay at 0. Next, we do coefficients to see if we have any dilation. We do have a coefficient, the number 3. Number 3 is multiplying by our x. So let's come over here. When we have a number, let me erase all these markings to make it easier for you. When we have a number multiplying with our x, remember what we do in this section. We are going to multiply by the reciprocal, okay? So I think I've cleared it up here. So going back here, our x value on our problem has a coefficient of 3, okay? Has a coefficient of 3. So specifically, it's going to be this top one being compressed horizontally because 3 is bigger than 1. But anyway, we're going to take that 3. You remember what I told you. You walk over here to this side, and you're going to take the reciprocal of 3 and multiply it by your x, okay? So what is the reciprocal of 3? Well, the reciprocal of 3 is 1/3. So I need to choose an x value to multiply 1/3 by. So look at all my blue points. This one has a -4, -3, -2, -1, 1, 2, 3, and 4. So which one of those 8 points is the easiest to multiply by the reciprocal of 3, which is 1/3? Well, if you guessed either -3 or 3, you're correct, because multiples of 3s are easier to multiply by 1/3. So I'm going to use the positive one, okay? So 1/3 times 3 is the same thing as saying 3 divided by 3. Let me give you a visual of what I mean by that. Okay, let me scoot this up a second, just in case you are not sure what I'm talking about. If I need to multiply 1/3 by 3, which is the x, okay, that's the same thing as saying 3/1. So 1/3 of 3 ends up being 3/3, because 1 times 3 is 3 and 3 times 1 is 3, which is just 1. So what I tell students to do is if you're multiplying by 1/3 or 1/4 or 1/5, in essence, what you're doing is dividing by this number. 3 divided by 3 is 1. Let's say you multiplied 1/4 times 8, okay? What you're going to do is just do 8 divided by 4, which is just 2, okay? One more thing, 1/5 times 15, okay? What would that mean? If you answered 3, that is correct. So when you're multiplying by a reciprocal, you're in essence dividing by that number, as long as this is a 1, by the way, okay? So we're going to multiply our x value by 1/3. Okay, so let's go back to our problem. We're going to multiply this x value by 1/3. So 3 times 1/3 is 1. So I'm going to change it from 3, 3, okay, to 1, 3, because the x is what's changing. There you go. See? I'm going to show you again. It was at 3, 3, but then I'm changing the x to 1 because I had to take 1/3 of 3, and it becomes a 1. But I want you to notice how the y value didn't change, okay? Does that make sense? I hope it does, okay? Just in case, just helping you visualize it here. The original problem was 3, not the original problem. The original point was 3, 3. Remember, I'm taking the 1/3 and I'm multiplying it by the x, okay? Because up here, that's my instructions. Take the reciprocal and multiply by your x. So when I multiplied 3 by 1/3, so I multiplied it by 1/3, my new point is going to be 1, comma, but this 3 does not change. So that's where that came from, okay? 1, 3. And when you move 1, everything else moves, okay? And then dilation's done. So now we have reflection. And we do have a reflection. We have a reflection, which is this. That is in front of our function. So when it's in front of our function, negative, so let me shift this down. When our negative is in front of our function, you are supposed to reflect in the x. So jump over the x-axis. So I'm going to take any of these points and jump them across this side. So 1, 4, no, that's not easy. Let's do 1, 3 will become 1, -3. So there's my reflection. Okay. And then you asked if there's any vertical movement. Last but not least, there is vertical movement, -2. And vertical movement always says do exactly what it says. You don't do the opposite. You only do opposite for horizontal. So down 2, you grab the green dot and you move down 2. By the way, horizontal and vertical movement, steps number 1 and 4, you always use the green dot. And that, my friends, is your answer. So if I submit, we get a green check mark. And that's how you do transformations of functions. So I hope that this has been a lot more easy for you to understand. All you have to do is practice, keep doing it, making the mistakes, and keep doing it and crushing it. I suggest that you write out the problems every once in a while, and you will learn by doing. Reach out if you have any other questions. Thanks for watching.